Hello students, have a nice day today. So once again today we will discuss with a new article of the chapter 3-dimensional geometry. So before that, I conclude what we have done in the last class. In the last class we have discussed about the family of planes. The family of planes passes through the line of intersection of the two planes is first plane plus lambda times of second plane, or second plane plus lambda times of the first plane is equal to 0. So by this way we got 5 types of questions: type 1, type 2, type 3, type 4, type 5, and that was included because earlier we have done up to type 7, then it is coming up to type 12 because 5 types of questions we have discussed. So before going to, because today we will discuss the most important article, that is the point of intersection between the line and plane. Point of intersection between the line and plane. Okay? We will see the distance of a point from a plane. Distance of a point from a plane. So let us see the distance of the point P. Suppose the P coordinate is x1, y1, z1, and the distance of the point from the plane. Suppose the plane is ax plus by plus cz plus d is equal to 0. So distance means perpendicular distance. So we are going to find what is PQ distance. Students, already I told you the plane is the extension of one variable of the line in 2D. In the 2-dimensional, what equation you know for the line? That is ax plus by plus c is equal to 0. So only one variable is added here, that is cz plus d is equal to 0. So you just recall the distance formula in the class 11. What we are doing? At that time we are putting the point x1, y1 on the line divided by s square plus b square root over the coefficient of x and y. Exact similar. Put the point on the plane. So the distance PQ, or we can say D, is equal to, in place of x, x1, ax1 plus by1 plus cz1 plus d divided by s square plus b square plus c square root over, we can take the modulus. Because the distance cannot be negative. It is the same formula. Only remember this formula. If it is asked to find the distance between the distance of a point from a plane, put the point on the equation of the plane divided by s square plus b square plus c square root over. Now, distance between the two parallel planes. Distance between the parallel planes. Distance between parallel planes. And which two planes are said to be parallel? If the perpendicular vectors of the corresponding plane will be parallel. Perpendicular vectors means what? The coefficient of x, y, z, that is ABC. That means two parallel planes, I can say, if the coefficient of the x, y, z either equal or they proportional. If both the planes, the coefficient of the x, y, z will be parallel. So let us see. I am writing two parallel planes. that is ax plus by plus cz plus d1 is equal to 0. That is plane 1, pi 1. Similarly, pi 2, that is ax plus by plus cz plus d2 is equal to 0. So, what I have taken here? The coefficient of xyz in the both the planes are same. That means the perpendicular vectors to the plane are equal. They are parallel. Parallel means their coefficients are equal. So, automatically the two planes will be parallel. And what will the distance between them? You just recall what we know in the previous classes, in the class 11, that was C2 minus C1 divided by a square plus b square root over, where C2 minus C1 should be under modulus. So, exactly similar, D2 minus D1 modulus divided by a square plus b square plus c square root over. So, this is the distance between two parallel planes. Distance between the two parallel planes. Okay? Take one small example. Take one small example. Say it may be 2 marks question. It may be your 2 marks question. Say question is like that. Question is like that. Find the distance between the planes. So, what are the planes given? The planes given, that is x plus y minus z, x plus y minus z plus 4 is equal to 0, and another one is x plus y minus z plus 5 is equal to 0. So, what should be the distance? You just mark here the coefficient of x, y, z in both the planes are same. Then you will declare the two planes are parallel. So, if the two planes are parallel, directly I can write the distance between the two parallel planes, formula d2 minus d1, 5 minus 4, modulus I can take, distance I can say small d, 1 square 1 square 1, minus 1 square is also 1, that is 5 minus 4 1 by root 3. So, distance is equal to 1 by root 3. So, here fortunately the coefficient of the xyz are same. Suppose the coefficient of the xyz will not be same but proportional. So, what should be our duty? Anyhow, by multiplying something in one of the plane or dividing in another plane, will equalize the corresponding coefficient of x, y, z. Then only you will call about, that is d1 and d2. d1 minus d2 or d2 minus d1, though we are taking the modulus, there will be no problem at all. So, these two things what we have discussed here, that is the knowledge of the class 11 straight line chapter, that is the distance of a point from a line and the distance between the two parallel lines. The same thing is reflected here in case of the plane. Okay. So, now we will come to the most important part of this chapter, that is the point of intersection between the line and the plane. Point of intersection between the line and the plane. Be ready to know the concept. Concept is what? Point of intersection. Point of intersection between a line and a plane, between a line and a plane. So let us take one line and the figure suppose like this. I am just telling the steps. Let the equation of the plane is x plus by plus cz plus d is equal to 0. Let this is the line and the point of intersection let be P. Let the line is there and the point of intersection be P. So what should be given here? So here equation of line and plane are given. The equation of the line and plane are given. I am not taking the line. The line equation is given and the plane equation is given. Correct? So in the above figure, let the line intersect the plane at P say. Let the line intersect the plane at point P. Okay. So let us see what we will do. Can I get the coordinate of the point P from the line, because the line equation is given? Though the line equation is given, we can find the coordinate of the point P in form of lambda. That is, the line equation is equal to lambda, x in form of lambda, y in form of lambda, z in form of lambda. So the third point I am writing, we can able to get the coordinate of point P from equation of line. That is the step 3. So once again, from the equation of the line, we can able to get the coordinate of the point P. And again, point P lies on the plane. So if the point P lies on the plane, so the coordinate of the point P must satisfy the equation of the plane. That means we will put the values of x coordinate, y coordinate, z coordinate at the respective place of the x, y, z. So I can write the fourth step. So my fourth step should be, say, the coordinates of point P must satisfy the equation of plane. Must satisfy the equation of the plane. Correct? Must satisfy the equation of the plane. That means if you put the values of the x coordinate, y coordinate, z coordinate here, and x coordinate, y coordinate, z coordinate must be in form of lambda, because it is coming from the line equation. So what will be then? After putting those values there, we will able to get the value of lambda. Then after we able to get the value of lambda. I am not mentioned anywhere in the lambda. We can write the point P from the equation line in form of lambda. I am writing in form of lambda. So we will able to get the value of lambda. We will get the value of lambda, and if we put the value of lambda here, then the coordinate of the point P is obtained. Hence the coordinate coordinate of point P is obtained. So my dear students, once again you please see the point of intersection between the line and the plane, the point of intersection between the line and the plane. So what should be given to us? The equation of the line is given and equation of the plane is given. If we will bring to the line equation to the Cartesian form, it is better, and this also to the Cartesian form to better. Let the line intersect the plane at the point P from the figure it is showing. Then we can able to get the coordinate of the point P from the equation of the line in form of lambda. I am suggesting you give this is equal to lambda. You can give any other constant k or p also, something like that. Then after getting the point coordinate here, though this is the common point between the line and the plane, the coordinate of the point P must satisfy the equation of the plane. After putting that, we will get the value of lambda. And put the values of lambda here, then we will get the value P, then we will get the coordinates of the point P, and which is the point of intersection between the line and plane. So by using these concepts, we can solve many problems based on the point of intersection between the line and plane. So let us come to discuss some question. I am taking one question from your textbook. From the textbook I am taking one question. You can check this question number 12 of the miscellaneous. Question number 12 of the miscellaneous exercise of your 3-dimensional geometry. The question is like that. Say, find the point of intersection. Find the point of intersection of the line passes through the points, these points are 3, -4, -5, 3, -4, -5 and 2, -3, 1, 2, -3, 1, -3, 1 and the plane equation is also given. The equation of the plane is 2x plus y plus z is equal to 7. 2x plus y plus z is equal to 7. Check the question. I am just reading out, you check the question. Find the point of intersection. Of the line which passes through the point 3, -4, -5, it is correct, and 2, -3, 1, it is correct, and the plane 2x plus y plus z is equal to 0. Find the point of intersection between the line and the plane. So my dear students, before solving the question, you just see what we have to do here. Because you see, the equation of the line is not given directly. The equation of the line is passes through 2 points. So we will find out this equation of the line using the 2-point form. Then the equation of the line will be ready and the plane is ready. So first the solution, how I am doing, see. The very easy, you can do it with me. Let us start with me. First we have to write the equation of the line passes through the points 3, -4, -5 and the point 2, -3, 1. So what should be the point? What should be the equation? X minus 3 divided by x2 minus x1, 2 minus 3, that is -1, is equal to y plus 4 minus 3 minus plus 4, it becomes +1. Then z plus 5, 1 minus of -5, it becomes +5, +5 plus 1, 6. Check. The equation is x minus 3 divided by -1, y plus 4 divided by 1 is equal to z plus 5 divided by 6. By using the 2-point form, we are writing the equation of the line. Now, the equation of the line becomes ready. Then you will write the same thing. Let the line intersect the plane at the point P. Let the line intersect the plane at the point P. Right now, let the line intersect the plane at P, at the point P. Then remember, what is my second step? Our second step is to find out the coordinate of the point P. To find out the coordinate of the point P, you can write it is lambda. Now, coordinate of the point P, let me tell. So, what should be minus lambda plus 3, minus lambda plus 3, correct. Lambda minus 4, that is also correct. 6 lambda minus 5. So, the coordinate of the point is here. Once again I am writing here minus lambda plus 3, then lambda minus 4, then 6 lambda minus 5. This is the coordinate of the plane, the x coordinate, y coordinate and a z coordinate. Now, you can put this coordinate on the equation of the plane. You can put this coordinate on the equation of the plane. Write down. Say, since the point P also lie on the plane, so it is sufficient to say the coordinate of the point P will satisfy the equation of the plane. Just you put in the equation 2 whole into x coordinate minus lambda plus 3. Similarly, plus y. Y means y lambda minus 4 plus z. Z is already 6 lambda minus 5 is equal to 7. Is equal to 7. So, multiply minus 2 lambda plus 6 plus lambda minus 4, 6 lambda minus 5 is equal to 7. 6 lambda plus 1, 7 lambda. 7 minus 2, that becomes 5 lambda. Then 6 minus 4 plus 2 minus 5 minus 3. So, minus 3 gone to that side. So, it becomes 7 plus 3, 10. So, lambda is equal to 10 by 5, that is equal to 2. Check the calculation whether lambda is 2 or not. So, we got the value of lambda is equal to 2. Now, you put the value of lambda in this coordinates. So, if you put this value of lambda in this coordinate, then what I will get? I am writing here. Now the coordinate of point P, lambda is equal to 2. So, 2 means minus 2 plus 3, minus 2 plus 3, 1. Then lambda is equal to 2 minus 4, minus 2. Then lambda is equal to 2, 6 into 2, 12, 6 into 2, 12, minus 5, 7. Therefore, finally you can write, therefore, the point of intersection between the line and plane. Therefore, the point of intersection between the line and plane is 1 minus 2, 7. So, this is the one of the question based on the point of intersection between the line and a plane. This is the type 1 question I can say. Okay. So, this is the type 1 question, the direct type of question that I have discussed, the point of intersection between a line and a plane. Now, we will discuss the image of a point with respect to a plane. The image of a point with respect to a plane. Image of a point with respect to a plane, that we will discuss. So, let us see the concept first. So, what is the concept? So, one equation of the plane will be given to us, and the point which image is to be find out, that will be given to us. The equation of the plane will be given to us, and the coordinate of the point P which image is to be find out, that will be given to us. Then how will get the image? Very simple. So, let us drop the perpendicular first. Let it intersect at a point Q, and from that point let the image of the point P is P dash. Image of the point P is P dash, and by the previous method we can able to get the coordinate of the point P, that is the point of intersection between the line and plane. After getting the coordinate of this point is given, this point also will get, let the coordinate of this point is alpha, beta, gamma. What is that? Now, that is the image of the point P. So, once again I am telling, listen. So, what will be the question? The question here, it will be asked to find the image of a point with respect to a plane. The coordinate of the point will be given, right? Point 1, the equation of the plane will be given. So, we will do the figure like this way. What is this figure? Now, let the point from point P, a perpendicular is drawn to the plane, and Q is the foot of the perpendicular, and P dash is the image of the point P with respect to the plane pi. The plane pi is there. So, my question is here, this coordinate is given, this coordinate will get it, and now Q will be the midpoint between P and P dash. By using the concept of the midpoint, we can able to get the point of the coordinates alpha, beta, gamma of the point P dash, which is called the image of the point P. So, let us discuss one practical question. One question we will discuss, find the image of the point 3 minus 2 1. Question, find the image of the point 3 minus 2 1 3 minus 2 1 with the plane or to the plane the equation of the plane is given. The plane is 3x minus y plus 4z, 3x minus y plus 4z is equal to say 2. Find the image of the point 3 minus 2 1 to the plane 3x plus minus y plus 4z is equal to 2. So already the figure is there. You see. So I can only write here the point is say 3 minus 2 1. 3 minus 2 1. So what should be the procedure right now? We will write let P, the coordinate of the P is 3 minus 2 1 and its image of P B dash with the coordinate alpha, beta, gamma. I have chosen this point as P and I assumed the coordinate of the point is P dash. Let the coordinate of the image, the coordinate or the image of the point P is P dash, which coordinate is alpha, beta, gamma. So now here in the given figure, in the figure Q is the foot of the perpendicular drawn from point P to the plane. From point to the plane. And equation of the plane is given. Equation of the plane is given. Equation of the plane. So what should be the equation of the plane? Equation of the plane is given already 3x minus y plus 4z is equal to 2. So the perpendicular vector n vector is equal to 3i minus j plus 4k. N vector means what? The vector which is perpendicular to the plane. So now you show here, this is the perpendicular vector n vector. What is n vector given? That is 3i minus j plus 4k. So my dear students, here the equation of the line PQ is not given. We have to find it. So how will get it? Because the line PQ is passing through a point and a parallel to the vector n vector. So the perpendicular vector of the plane becomes parallel to PQ. So now I can write equation of line PQ passing through the point x minus 3 divided by 3 is equal to y plus 2 divided by minus 1 is equal to z minus 1 divided by 4. Check it. X minus 3 by 3 is equal to y plus 2 by minus 1 z minus 1 by 4. Now, so the equation of the line PQ is ready. Let us come to the coordinate of the point Q. Let it be lambda. Now, coordinate of Q. So कितना हुआ ना 3 lambda plus 3 3 lambda plus 3, then minus lambda minus 2, correct, then 4 lambda plus 1. That is the point Q. Now we are going to find the point of intersection with the line and plane, nothing more that. We are going to find the point of intersection between the line and a plane. Now put the point Q on the plane. So now it will satisfy the point Q coordinate to the plane. So 3 whole into, you have to write one sentence here. We have to write one sentence here. I am taking out this. Say, the point P also lie on the plane. So it will satisfy the equation. What is that equation? 3 whole into 3 lambda plus 3. 3 lambda plus 3. Then minus y. Minus y matlab ये both will be plus lambda plus lambda plus 2 plus 4z. 4 into z, 4 lambda plus 1 is equal to 2. Solve it. So 3 into 3, 9 lambda plus 9 plus lambda plus 2, 16 lambda plus 4 is equal to 2. 16 lambda plus 4 is equal to 2. So let us check whether the calculation is correct or not. Let us check 9 lambda plus 9, then lambda plus 2 is correct, 16 lambda plus 4 is correct. So 16 plus 1, 17 plus 9, 26 lambda. It is coming 26 lambda. Write down 26 lambda. 26 lambda. 9 plus 2, 11. 11 plus 4. 11 plus 4. 11 plus 4 कितना हुआ? 11 plus 4, 15, and there this side is 2 is there. So 2 minus 15 minus 13. So lambda is equal to minus 13 by 26. That is minus 1 by 2. So lambda is minus 1 by 2. Correct? If the lambda is minus 1 by 2, let us put the value of lambda here. Let us put the value of lambda here. Now the coordinate of the point Q, from this point to this point I am coming. Say 3 into minus 1 by 2 plus 3. Then minus means plus 1 by 2 minus 2. Then 4 means minus 4 by 2 plus 1. So it is minus 3 by 2. Minus 3 by 2 means 3 into 2, 6. 6 minus 3, 3 by 2. 1 by 2 minus 2. So it is minus 3 by 2. Then it is cancelled. Minus 2 plus 1. Minus 1. Check. Check yourself, because each step you have to check whether it is correct or not. 3 by 2 minus 3 by 2. 3 by 2. So I can write here the coordinate is 3 by 2 minus 3 by 2 and a minus 1. This is the coordinate of the point Q. Minus 3 by 2, sorry, plus 3 by 2 minus 3 by 2 minus 1. Then you will go to the image. Then you will come to the image. Then you will come to the image. So you have to write here. Now you have to write here. Now Q is the midpoint. Q is the midpoint between P and P dash. By using the midpoint formula, alpha plus 3 by 2 is the x coordinate of this point. 3 by 2, 2 cancel, so alpha is equal to 0. Similarly, beta minus 2 by 2 is equal to minus 3 by 2, cancel, so beta is equal to minus 1. Gamma plus 1 by 2 is already, what is the z coordinate? Minus 1. So gamma is equal to minus 2 minus 1. So gamma is equal to minus 3. So P dash coordinate alpha 0, beta minus 1, gamma minus 3. Check. 0, minus 1, minus 3. So finally you can write, therefore the image of the point is 0, say minus 1, minus 3. Therefore the image of the point is 0, minus 1, minus 3. Okay. So thank you very much for your patience hearing once again. So this is the most important part, the point of intersection with the line and plane, and particularly we have shown how to find the image of a point with respect to a plane. Thank you. Have a nice day.